So welcome everyone. Thank you for joining our TrafficLink user training. Today we're focusing on detection and counts. So it's going to be an exciting one. We're going to do one particular example that I did in the last week that I thought was kind of a scenario that we haven't done in one of these sessions. It's a dual camera, so it's a little bit more than what we've done in the past. So we'll definitely jump into that one and go through some complex examples that I'm pretty excited about. But just quickly, for those that don't know me, my name is Brett Rogerson. I am a sales engineer on the sales team for Miovision, and been with Miovision for quite some time. So I've had the exciting opportunity to actually get involved with our customers quite a bit and really help our customers take advantage of our products. So I typically host these sessions once a month where we get into quite a bit of the feature functionality type items, and we really start exploring the product itself. So I try to kind of pick off some pretty fun examples throughout the session. Sometimes it is a little bit repetitive, but we host them every single month so that the opportunity for others are always there. You can always jump in, learn some of the basics, and sometimes some of the complicated elements of it as well. So that's a little bit about me. Today, our agenda is very much focused on detection, very much into some of the pre-work that needs to be done to set up detection, and actually what we need to do to get it working in general. So I'm going to spend a few minutes in the slides themselves. I'm not a big fan of slides if you've seen any of these sessions before, but we'll certainly get into some of the pre-design, like what channel design, what BIU configuration we need, and some quick examples to think about before you even start configuring detection. And then we'll jump right into, we'll probably go right into number 4, the complex configuration, because it kind of solves a few things. When I say complex, it's not, there's not a prerequisite to the knowledge here. Like, you should be able to pick up what I'm doing. There is basics and some normal things along the way. The reason why I picked the one intersection today is mainly because it's a dual camera, and I've normally focused on a single camera configuration in the past. But in any case, let's get going. So with that in mind, actually, do I have this other slide here? No, I don't. I removed it. Maybe I'll just pull this up here for one quick second. As always, I do cover quite a bit of content in these sessions. Please take advantage of the chat window or the question window. You can certainly post questions to me, and I'll pause periodically to see if there is any questions outstanding. If I don't get to your question, I'll try to follow up following this session. Or please reach out to me, brogerson@miovision.com, contact your local distributor, or contact Miovision support or sales. We'd be certainly happy to help. But definitely reach out if you have questions following this, and don't be shy. So let's get back into this. So when we're thinking about detection, this is always the first step. The first step of detection is always, what is the design? What is the plan? What channel scenarios are we actually looking for? How are we actually going to configure this intersection is always question number 1. So if you ever worked with Miovision technical account managers or with our partners, this is usually where the conversation starts. This is usually what we're looking at. What are the phases? So standard design, you can see on this image here, you can see that we typically follow the standard 7 and 11 rules when it comes to what the intersection is, but none of this really matters on the Miovision side. We can design channels from 1 to 64. So we have access to all 4 detector racks over SDLC, and we can assign our channels to any zone. So our side doesn't matter too much. Where this is super important is on the controller side. So when Miovision draws a zone, or when you draw a zone in the Miovision tools, what is that zone associated with on the controller side? That's where it's really important. You got to do both sides. So we got to understand what is the current phasing and what is the current channel design. And very often, every cabinet that I've seen, or most cabinets that I've seen, often have a diagram like you see on the right, or some sort of sheet that clarifies what the timing plan design is and what channels need to be associated to those phases. Typically, they're fairly standard, like one-to-one. Channel one, detector channel one calls signal phase one. Let me just see what this question was. Yeah, I can definitely send out some of this following the session, so no problem there. Yeah, this documentation step is a pretty important one, so I like to double down on it as much as I can. So once we get through this, once we understand what the channel design is, then it's easy to go into the systems and tools to really get going and really get it configured and whatnot. So often we ask for this, we keep them in folders and we can save them at the intersection. Now there's a couple steps to actually enable actuation, or actually to configure it for the channels that we actually want. So very often there's what we call the BIU detector configuration. So on the controller side itself, it needs to be enabled for certain channel sets. A BIU detector rack channel, or BIU 1 or detector rack 1 often refers to channels 1 through 16 over SDLC. Channel BIU detector rack 2 is 17 through 32. Detector rack 3 is 33 through 49. And then the last one is, 49 and 64. So it gives you the full range of all 64 channels, but the controller also needs to be enabled to do that. Otherwise, the SDLC input wouldn't be taken. There are other ways to integrate with traffic cabinets. I'm not really going to get into those today because SDLC is our main form of communication with the controller. There is wiring harnesses and a subset of SDLC inputs as well that allow us to integrate with controllers like 2070s or some older ones like TS1s. But generally in the SDLC world, it's about, or in the TS2 world, it's more about which channel set does Miovision need to be associated with. So you go in the controller, make sure these are enabled. The second step is actually associating a detector channel with a phase. Very often you'll see it like the kind of little diagram I drew here on the left. Detector channel 1 relates to phase 1. Detector channel 2 relates to phase 2. But every city and every region I've been in can do that slightly different. Sometimes you're using further on channels or whatnot. So it is really important to understand this before you start configuring. The main reason may be obvious, and maybe I'm just double downing on the same point, but if you don't know what channel numbers to assign to the zone, then the Miovision system doesn't know how to actually communicate back to the controller that there's a vehicle in a detection zone. So always start with this step, always understand what is the phasing, what is the timing diagram, and what are the associations of channels. One last point on the controller side. Is actually more around the coexisting of other detection systems. So because of the BIU configuration back on this page, where you can decide BIU detector rack 1, BIU detector rack 2, Miovision can actually do the same thing on our side. On our side, the scenario, we can configure and have us just on one of these detector racks. So Miovision could be 17 through 32 only, and an existing detection system, say like detector, like loops in the ground or whatever, whatever that may be is actually what's going on. So you can actually have those coexisting together, and you can have them coexisting together and they can work as long as they don't overlap on BIUs. So that can certainly help us coexist with other detection systems. So with that in mind, once the controller side is sorted out, then on the Miovision device configuration, so our SmartSense device is the actual detection processor in the cabinet. You can essentially do the same configuration of the device. How is it connected to the controller, which is the IO configuration here? So is it just standalone? Maybe it's a count station for turning movement counts. That's where you'd select none. If it's into say an old TS1 style cabinet, if there is an ABC type integration that we used to do in the past, we don't do so much anymore. SDLC is the most common one, and then GPIO is our term for the wiring harness. And so often we just select SDLC, and then that enables the second round here, which is on what channels does Miovision need to be on. So what channels are we going to be configuring in the detectors? And so in this case, we're selecting 17 through 32. That means when we go and draw the zones in a few minutes, we are only focusing on, or we're only able to assign 17 through 32. And that's totally fine, completely up to you to decide what access to channels you want the system to have, or what set you want them on. So if you only want your Miovision detection systems on channels 49 through 64, you can certainly do that if you want to. One important piece that we often don't talk about, it's a pretty handy feature, you can use it, you don't have to use it, is this enable actuation button. Enable actuation is really allowing you to have a standalone system plus so it's a standalone system, you can just have it run collecting data and not inputting anything to the traffic controller, or you can enable actuation and then it actually starts outputting or providing inputs to the traffic controller. So you can actually decide if anything is transmitting over that cable or not, and that's simply what that toggle does. We often use this during the installation phase. So we can get everything up and running, get it configured, get the zones operating, visualize that on the video, and then once you're happy with what you see, then just flip the switch and then everything starts working all at once. And then that way you can really monitor it and see how it works as you go. So it gives you some configuration on the device. This is edit cabinet device section of the platform that we'll go to in a second, but it should be pretty straightforward. I think that was my last slide. Yes, it was. So just a quick recap. What is the timing diagrams? What is the channel design that we want? How does this intersection operate? Can we save that documentation on the intersection for future troubleshooting so that you remember or you have something to refer back to in the future when it comes to the configuration? Make sure the controller itself is enabled for the detection inputs. And then the following one is make sure channels are actually associated to the correct phases. And then make sure Miovision side, our device is actually enabled to talk to the traffic controller. Once you set up all those steps, or you're happy with what you've decided and what the plan is, really got through the planning exercise, then you can get right into the configuration of the system. All right, so let's do that now. Let me just see here, is my screen still sharing what I expect it to share? Perfect. So we're going to configure an intersection. One of our customers graciously let me show this example today. It's actually kind of a standard design of an intersection. So we have the north part here. I'm just looking at Google Maps just to kind of explain it. We have a north part of the intersection over here that has a set of signals, and also the south part, all on the same traffic controller. So that means these two three-way intersections are actually operating together. And because they're so far apart, and often when I'm like measuring and I'm actually looking at different things, I use Google Maps to actually measure it out. The distance that these intersections are, almost stop bar to stop bar on either end, is almost 300 feet apart. So this is definitely one of those scenarios where dual camera is required. And so the team went out and we installed the dual cameras at this location, and now we can get it all configured and sorted out. So this is a great example of how we're going to have we're going to configure two different cameras on the same system. So let's jump over here. So let me move this thing out of my view here. So we already had this one kind of going, so I'm going to kind of go back to the beginning. You can kind of see what our plan of design is here. I had the channels already pre-configured from a similar document that I was just talking about to really understand. But with this, what makes this a little bit more complicated, because it's an offset intersection, is there's this center part of overlap channels. So this actually has an overlap A and overlap B for the inner part of the two sides. So what this really lets me do is we're going to configure the north intersection and the south intersection almost separately, but then we're going to put them into the same video detection overlay in a way that we can see it operate all together. So let's go over to the camera design. Actually, let me grab the channels configuration here, because this is a piece that we need. So it's all 1-to-1 with northbound being 2 I'll just open this up in, there's some like paint just so I can store it. There we go. So let's go back to, so let's just go to the video for a second and look at it. So if you haven't seen a dual camera location before, this is what it looks like. You do have two sets of cameras. We can play them both just so we can get a feel for the intersection a little bit here. Let's see if this loads up over the screen share. Let's get that to reload here. So we do have our dual camera set up, one on each corner. So we have the first one on the south side. So the one on here on the right is actually the south part of the intersections, and the one here on the left is the north side. And you can kind of see the white van on both sides kind of coming up to the next intersection. So while both cameras are separate, we're going to configure them into essentially one overlay in a way that we can actually see them operate together. Because this is in reality a single traffic controller, a single intersection, just with two different cameras. So let's go, now that these are up and running, let's go and configure them. So on the bottom left, I'll just go to the bottom left here, a configuration view. We'll go to our configure smart sense in the top right. You can see that I had it configured already, but that's okay. We'll recreate this. So let's go to our configure smart sense options. Get our images here. So we can configure both these cameras separately now. So we have our camera on the north end and our camera on the south end kind of next to each other. Then over here on the top, we can toggle the configuration for both of them separately. So we'll configure each camera individually and then we'll deploy them together. So let's configure the first one. So this first one here on the left, knowing where the camera location is, so you can see that there's what is that, like an IHOP restaurant right there. If I went back to that Google image here for a second, just to have a view open, you can see that IHOP's right there. So we're pointing northbound. So this is pointing northbound on that street, and this one's actually on the north side of the intersection. So just to double say that, on the north intersection, the camera's on the south side, and on the south intersection, the camera's on the north side. And so just knowing where the cameras are, it really helps as well. And then you can get your orientation down and then get everything configured. So we're going to start with the first one. Very similar steps. So if you've seen any of these sessions in the past, it's all the same steps, just individually done. So you have to kind of keep track of which zones you want on each intersection and how you wanted those actually allocated for channel design. So same first step, place the pin on the camera. So follow the video if you want to. Really what we're looking for is to line up some of the straight edges. So we're trying to line up some straight edges with the signal pole, with some of the building markers, some signal poles on the other side of the street. That looks pretty good. Doesn't have to be perfect. Again, the purpose of this step is to really give the camera a starting point. It really tells the camera where is down. And then in the second step here is how high is it? Having the height of the camera directly from, say, the contractor, that's super helpful. Or you can use this little estimator tool. This camera is right around 32 feet. And so you can see how it matches that car almost identically. This little tool is actually just like I think that is a Honda Civic really. So trucks will be slightly bigger, but sedans will be really close. So you can see how that works. And so then you get your height, you input that. There's again a little video on how to determine that. Then the last step, back to Google Maps and give the camera some directionality. So because the camera's on the southwest corner, it's looking at the north side of the intersection. So if you didn't see that right here, it says camera direction north. So we'll say done. So that's step one of our first camera is ready. Now we can get into the detection configuration. So same rules apply when you're doing the configuration. We in total have 9 views. And so a view is essentially an approach. When we want to do an approach configuration, what we're looking for is how many of those views of that individual approach that we want. And we can do up to 9, including the turning movement views. So we'll really have an option of 8 or sometimes 7. depending on how many legs there are at an intersection. In this case, there's really only, we have 3 approaches at each intersection. So we have the north, west, and south at this one, and at the other camera, we'll have the north, south, and east. So really that's 6 views in total, which is perfectly fine. That fits within our 9 views that we have in total, or our 9 approaches plus a turning movement line. So now we can start configuring this and start working our way around the intersection. So it takes you through, it is a guided process. It does take you through all of this. So if you haven't actually configured one in the past, the steps do take you through it pretty quickly and pretty easily. Just make sure you follow each step as you go. First step is always assigning it to an approach label. In this case, it said westbound, but this is actually our southbound approach. It takes our label here, and as in the label, you can always update the label. This will be the label that's actually in the video itself. So when you're looking at the video, try to make sense of what you're looking at. The label that it uses is right here. That can be changed. You can make it whatever you want. You can name it, say, the phase numbering if you want. I know this intersection has our southbound through is phase 2, so we could label this as, say, phase 2, just so that we know in the video. Next step, so now we just get right into drawing detector zones. So first one, we'll draw a single box here. So this is also where it comes down to what your standard design is, or how you want the particular zone to operate. You can do lane by lane configurations, meaning each lane has its own zone, or you can do one big zone for the entire approach. It depends on how you want to program the traffic controller to some degree. And what I mean by that is, in this case, southbound, the southbound approach that we're doing. So southbound, oh, sorry, this was actually southbound, so phase 6. Let me go back and just change that. Southbound phase 6, just so we don't get that confused. So this is southbound phase 6. I want to assign this to a channel set. We said 17 through 32, and you'll see what that is in a second. But I only need one input for this approach. If I wanted to do 2 zones for each lane, then I need 2 detector channels. Miovision currently only supports 1 zone to 1 channel, meaning we don't necessarily support this zone or this zone channel having a single channel. It's 1 zone, 1 channel, which means you'd have to update the controller a little bit if you wanted to have multiple lanes individually talking to the controller, which can certainly be done, but not always necessary. So in this case, we're going to do a single zone. At this step of the configuration workflow, you're actually just doing all of the zones first. So we have our vehicle zone. I'll also add in our crosswalk zone because we only have the 1 zone on this approach. Draw that in. So for those that don't know, this is the crosswalk count zone. It allows us to count pedestrians in the crosswalk zone itself. It also allows us to do some of our performance measures like pedestrian compliance in the zone. So are they crossing when they're supposed to be crossing? But if you're just looking at detection and counts, this is just a count zone for that purpose. So this view is done. We only need the 1 zone on this one, so we'll hit continue. This is on our north side, and then this zone is our southbound through phase 6. You want to give it a label that obviously makes some sense. But because we're on detector rack 2 and we're using 1-to-1, so phase 6 would actually map to channel 22. So channel 22. So in this design, everything's just offset by 16. So channel 17 would map to phase 1, channel 18 would map to phase 2, channel 19 would map to phase 3, 4, 5, and 6. So for this channel, because it's a through only, they can't turn right here and they can't turn left anywhere over there. This zone itself is just a through movement. We want it to detect all vehicles, motorized and bicycles. So we'll just say everything. It's a present zone. We don't need any delay or extend on the zone specifically. We can just use it kind of as is. And so we'll hit done. So now this approach is now configured. Now we can move on to our next one. So just to move on to the next one, we just click on the video image there and we create a new approach. So now that that last one was our southbound approach. This one is our eastbound approach. So that's good. Eastbound again was, if we go back to our handy little diagram here, eastbound through is phase 4. So it's direction eastbound, we can say phase 4. We'll hit continue. So now we want to draw the zone. So in this case, there's actually 2 lanes. There's the left and the through. According to our timing plan, we have the eastbound through and an eastbound left is not activated. So we're not actually, so you don't see that there's any colors in there, green, yellow, or red. So that phase is actually not a real advanced left turn phase. So this is really just a single phase for this entire approach. So again, we don't need 2 zones for that. We can get away with 1 and just stretch it across the whole approach. One thing that I'll call out here, because there's a driveway. Just stretch that into here. So just on the zone drawing itself, there's a couple ways to think about this. So first, the directionality of the zone. So there is a specific direction that we're looking for in the zone. It does help us filter out things like kind of like wrong way drivers, or say there's a left turn that is encroaching the movement quite close. Directionality filters out a lot of noise in the zone. However, when you get to a scenario where the vehicle isn't necessarily entering where it's green and exiting where it's red, a vehicle actually can enter from the side. So if I say stretch this back even further, a vehicle could enter the zone from the side. Since they're not actually allowed to turn left, this may not be as applicable, but it's still looking for directionality. So if the vehicle enters from the side and turns towards the red, it'll actuate. If a vehicle enters from the side and turns towards the green, it will ignore it. And it's assuming that it's turning left. So every once in a while, you'll get a vehicle that does somewhat of a roundabout loop into the zone where they will go left initially, and then they'll turn back right to go and say the left lane. It will actuate for them turning as soon as they turn right. So if you really watch the video closely, you'll see some of that behavior, and the zone will turn green once the vehicle has pointed and started progressing towards the red. So you don't necessarily need to enter from the fully from the one direction. You can come in from the sides, and that is supported pretty well. But you may want to think about how that is accounted for and when the zone will be triggered based on when they're entering the zone, or if you want to just let them do what they do, and once they end up in the right spot, it will detect them properly. Which leads us to my second point on the detection zone length itself. This again is for you to decide. Miovision is really looking for at least a single car length. If you have high truck volume, you may want to go for a zone that's at least the length of a truck. But really, this is about how you want your timing plan to work. If you say you had a really short zone, then there's lots of opportunities for the channel to actually drop. And then, so in between each car. So when the zone's really close, every time a car enters and exits, the zone will drop the call, then re-engage the call, then drop the call and re-engage the call. It'll cycle through that because the zone is really short. If you stretched it out longer, then the first car hasn't left the zone by the time the second car has entered the zone, which means it stays a constant call of the zone, which then your gap outs between cars doesn't necessarily need to be accounted for until they've spaced out enough, say like 1 to 2 car lengths or something like that. So you could plan around what you want your gap out scenario or your termination of the phase to end based on how much time there is between cars, or you can account from that just by stretching out the zones appropriately. Many cities have a standard design of what they want the zone lengths to be, and just follow your standard design. It doesn't necessarily matter to us. My only recommendation is that when you have high volumes of trucks, when truck percentages are really high, to really consider an appropriate zone length that matches a truck length as much as possible. When you do that, it minimizes error quite a bit. So we got our zone here. Again, let's add our crosswalk zone. This doesn't really matter which direction I go. It kind of just cycles around. it knows which side of the road. It's based on which side of the road it's on more than anything. But so this zone is on the west side of the intersection, but our eastbound traffic. So this will be our eastbound through, it's more so eastbound left, right in reality. But I called it, I think, an eastbound through over here. So that's channel 4 or phase 4. So phase 4 channel, and because we're offset, this will be channel 20. So similar, same thing on each one of these channels. So because this is a left right, we choose the left right one. Again, all vehicles, presence, and no delay or extend on this zone itself. I guess one thing I didn't mention is how far into the intersection you want to draw your zone. Most people just go right to the stop bar. Especially on these side streets, you may want to consider extending them a little bit, maybe even adding a delay if they're turning right. So you could consider different operations with delay on some of these minor streets so that it doesn't actually cycle the intersection preemptively if the car is just going to leave and turn right. So you could think about a delay on this type of movement, or you could extend the zone a little bit or move back to the stop bar, depending on exactly how you want to work. Again, all for you to decide, very configurable. So channel 20, presence, we'll hit done, and we'll hit done on that approach as well. Because we're still configuring the first camera, we have the inner part of this dual intersection location on this side. So we'll click on the base one here. And again, this is northbound. So we'll draw our northbound detection zone. The controller itself may not actually be programmed to take in inputs on overlaps. It could very well be, it depends on how you want it designed. But we do want to add the zone if the controller is expecting a zone. One thing to note, let me just finish this first. This would be our, go back to our zone. This is our overlap A, which is our northbound through in the inner part of the intersection. So we can just call this overlap A. It is associated and it's overlapped with our northbound through phase 2. And so because this is not necessarily your standard 1 through 8 phasing, you may want to give it a channel number that's further up the line. So if channel 8 is going to be associated with channel 18 is going to be associated with phase 2, then maybe we can just offset it to channel 16, which is just the same one, just further down. This is also just a through movement, and then we'll say this is channel 26. Again, though, by making that decision, the controller also needs to be programmed to accept that. But if, say, you wanted your channel design to be more so on something more custom, you certainly can just choose the channel that you want. Completely up to you. So one thing I wanted to call out here is the pedestrian zone itself. So currently the Miovision system only supports 4 pedestrian zones per intersection. This is something we're working on, something we're trying to enhance. But in this scenario, we technically have the 3 crosswalks at the north part, and we have the 3 crosswalks on the south part of the intersection, which means we have to somewhat pick and choose where we want our counts to come from. I've been in this scenario, what I did, so I did the north one here on this side and the west side approach crosswalk there. For here, I can't really do this one because I'm limited on zones, but on the south intersection, I'm going to do the south side and the east side as well for the pedestrian zones. So something to really think about of which ones do you more specifically want counts from. If there was one of these that were more important than the other, so instead of doing the north side, you want the south one because there's a parking lot here, you certainly can move them to where you find appropriate. But at the moment, we're limited to 4 per intersection. And that's something we're working to expand based on some more of these complex offset type intersections. So in any case, hopefully that's understood. Let me just check to see if there was any questions in here. Oh, there was a different question. All right, I'll answer Matt's question here. Let me just go back a step. So there was a question asked in the chat here. where'd my question go? Is the hypersensitivity option for the detector input setting going to have the reverse option of low sensitivity if that feature was released? Oh, I see what you're asking. So this hypersensitivity mode toggle right here is what the question was about in the chat. Let me just put that, there we go. So this hypersensitivity mode is a support mode that Miovision has that we can leverage. A good way to explain this is, so generally in our system, we have a couple fail-safe operations. Obviously the device fail-safe operations, where if say a device component has an issue, the intersection goes into a fail-safe constant call, providing recall essentially at the intersection. Then we have a couple weather-based modes, one being glare detection, and often we refer to that one as super dynamic range of the video. One of the challenges with the 360 camera is the lighting conditions themselves. So when you have a much larger range, you can only have one contrast or one light range or one range of light necessarily programmed at any given time. What we have for our glare detection fail-safe mechanism is called a super dynamic range, which can actually be dynamic based on the lighting conditions and allow us to flex in glary, rainy conditions and be normal conditions when it's in normal conditions, actually using lighting appropriately. And if it gets to a part where glare or the contrast and the brightness of the intersection becomes too much, it'll go into an automatic fail-safe or an automatic mode where it'll actually just place more detection calls as a fail-safe. And what that mechanism that's actually being used to support glare and fog type detection is actually this toggle here called hypersensitivity mode. When it comes to actually detecting a vehicle in our video, we use the machine learned AI. Our system knows what a car is, what it's looking for in terms of attributes like windows, wheel wells, and hood. It's looking for the features of a vehicle. However, in these adverse conditions or in these poor conditions of the, say, various weathers, those features get really hard to see. And what hypersensitivity mode is basically falling back to a method of detection that's often referred to as background subtraction. It's actually starting to look at more pixelization change as a backup plan than just looking for features of a car, often used in these poor condition scenarios. So as a Miovision support rep, I have the ability just to toggle it on and turn on what we call this hypersensitivity mode, where it'll favor just movement in pixels versus actually using our AI machine-driven location. And our system can automatically toggle between when it's looking for just movement in the zone versus when it's looking for the car specifically based on the condition in the environment that it's in. But if there's, for whatever reason, there's a problem at the intersection where, say, detection is not being placed as expected, we can go in and turn on this hypersensitivity mode manually. That would allow us to place a little bit more calls on the movement itself. And what this does is it helps us as like a stopgap or a troubleshooting mode that favors detection calls a little bit more. You do end up with a lot more false calls or false positives in that scenario, mainly because it's just looking for pixelization changes, which obviously like shadows and weathers can cause some false calls. But in that whole design, the reason why we're doing that is because we're favoring cycle the intersection and don't miss a car. You can't, the whole design is don't miss a car, but if you place false calls, that's less bad than missing a car. So we do have the ability to toggle on some of these modes manually, and some of them are also automatic. Hopefully that answered Matt's question. All right, let me just finish up this one. So we got our first intersection, first camera here done. So let me go back to the second view. So now we can go over, toggle over here to the right, go to our second camera, and go through the same steps. I'll do this one a little bit faster because you kind of hopefully get the point to some degree. Place the camera, draw out a camera, a car. If you don't know the exact height, again, you can just scroll to it. This again is about 30 feet. This one's a little bit lower, it looks like. Again, we are directionality, so we are on that south pole, and again, looking oh, sorry, we're on this pole, it looks like, looking at that building. You can kind of see the image on the right there of the building itself. So we're more so looking east in this case. And then we'll work through the same steps. So we'll go over to this far side first. This is actually our northbound, so make sure your directionality all makes sense. This is our phase 2. We'll add our vehicle zone. So this is interesting. There is a car park there. Because this is a parking lane, this is for you to decide somewhat of how you want this to work. Miovision's system does have a forget time. It is configurable. Generally, our forget time is 3 minutes. And so what that means is that if a car, say you did draw this zone right out over the parking lane, if a car comes into this zone and parks there, it will hold the car. It will hold the call of this zone for about 3 minutes. And then once it realizes it's a persistent parked object, after 3 minutes or often more than one cycle, it'll actually ignore that car and drop the call until it moves again. Once it moves again, then it'll pick it back up. That is configurable. I've seen some customers go as long as 7 minutes or even 10 minutes, depending on the intersection, but generally we default to about 3 minutes of a forget time. You can remove that forget time as well, so you can make it so that it holds it constantly as long as there's a car parked in the zone. You can certainly do that. But what most people do is they actually just avoid it. Just don't draw the zone there. So it should be pretty straightforward. If a car is in the zone, great. If it's not, then it's not an actual travel lane. So you can't ignore this, but every once in a while, this car will move forward to actually enter the intersection, but there's no zone there to account for it. So what you could do is do something to try and capture some of the movement without minimizing some of the calls. So sometimes you'll see this somewhat stretched like that a little bit. But in any case, normally what we do is we just avoid it altogether, just so that it doesn't place any false calls that we don't want. But if it does park in your zone, that's not the worst. It will forget it after a certain amount of time. So we got our one zone here. We'll add one of our 4 boxes as well. We'll stretch that out. Don't have to necessarily stretch it all the way. It does help when it's looking at the data for, say, performance, but in counts, it doesn't necessarily matter. It comes from the center line of the crosswalk when we're counting. So even if you drew the zone like this, it's still just going to be counting from the center point, which should still be relevant regardless of where in the crosswalk they are. Shouldn't impact the data too much. We'll continue. This was our northbound through phase 2. And you can see that my labeling convention here is very consistent. So I'm going with what is the direction, what is the phase, and what is the channel. Other people think about it in a different order. So what is the phase, what is the direction, what is the channel? Completely up for you to decide. Just choose something consistent and choose something that you understand, so that when you're troubleshooting it and you're trying to understand it in the future, it makes sense to you. So I usually do direction, phase, channel. And since this is channel phase 2, we'll use channel 18. So this is a through and a right, so they can actually turn right here. So we'll say through right, all vehicles done. This is our south side crosswalk done. We'll do the other side of this intersection. This is now our westbound side. We only have one movement here again, so we'll add just our one zone. This also looks like a parking. It's going to be close for the parking. I can imagine people will come right up pretty close. You may want to keep this one tight in case cars park up really close to it. But again, if a car parks right in that zone, it will forget it eventually, but it may cause some cycles that you don't want. We can stretch it out a little bit. We can add our pedestrian zone again. And you can see, like, I was going pretty slow in the configuration, but once you get the hang of it, the goal is to be able to configure and get an intersection up and running in less than 30 minutes. So once you get the hang of it, you're really comfortable with it. You can see it, you can pick up the pace quite a bit. So this was our northbound, sorry, on the other side now. This is our westbound through, westbound, it's kind of a right, left, but not that big of a deal. This was our phase. If we go back to our diagram, westbound, phase 8, channel 24, which is the last one on our line here. This is a right or left right, and we'll say done, and we'll finish that approach. So we'll do the last inner side here. Again, this is southbound, so I've got it right that time. This case, I believe, if I go back to the diagram, we do have a southbound left in this case, which is pretty exciting. So we have the left and the through. I guess left turns are exciting to me, but we'll draw this. We can draw it right in all the way back to where the lane is. But again, depends on how you want your gap outs or your termination of a phase to really work. This intersection actually has a lot of different scenarios in it all at once. So this is actually a pretty good one. We'll draw that out. Again, you can go as far as you want. So similar to what I was talking about with the ped zones, we only had 4, so we used 2 on the north one and 2 on the south part of the intersection, which means I have to skip one of these approaches, which is totally fine, but you may want to choose which ones. So this is southbound left. I'm assuming this is phase 1. Phase 1, channel 17. So left, channel 17, presence, all the detectors. Good. We'll go to our second zone here. This is southbound through. Assuming phase 6. But this is our overlap channel. So this is actually looking at our overlap B southbound through because it's the second part of it. So this is our overlap B channel. So since we used kind of 1 round offset, if channel 22 is our phase 6, then channel 30 will be our overlap part of the same phase. And it is just a through movement as well. I'll add that to my label. And then done. So now on this camera, now I have each one of those approaches also done. If I go back, now we can see we have our first camera done and our second camera done. So then the last step of all of this is the turning movement count. So right before I jump to the turning movement count, let me just check to see if there's any other questions. Nope. Okay, I'll keep going. And so the last step here is the turning movement count. And so there's another slight trick and thing that we're slightly working on right now is we can only draw 1 turning movement count. And what that means is that we can only draw one box and we have to choose which camera we want it on. We don't quite support, we don't have the turning movement count design where we can actually stretch it across 2 cameras, but we can put specific movements on each one of the cameras. So that means we have to somewhat choose which movements we want from each camera, but maybe as an obvious point, you'd think that you'd want 1 through here, 1 through there on each one of the cameras, but you can just do it in any way you really want. So if we choose our first camera here, the left camera, we'll go to the turning movement count. And so each one of these steps can be equally done. So southbound, we'll rotate this to match our intersection a little bit better. I like to include the crosswalks when we're doing the turning movement, just have it expand out to the crosswalks because you'll see why in a second. So southbound, northbound, westbound, eastbound, all the approaches make sense. We can adjust our ins and outs. So again, green in, red out, same as our detector zones. And then we have like a one-way street. So I'll hover over the red and I'll hit the delete button. Now you can't see me actually pushing that button, but you can just hit delete. Then we have our in there. This is both ins and outs. So we'll stretch that to match. And then we don't have an approach on this side, so we'll just delete those. And then we have that movement there. And so now we have all of our ins and outs defined. And then we go into each one of the intersections that we want. And so because there's 2 lanes, we always recommend that you do 1 lane for 1 line for each lane. That way our accuracy is a little bit better when you're doing lane by lane. In the turning movement count at the end, they will be combined. It doesn't really impact the data set, but it does help you get a little bit more accurate with which lane are they in. And our API does have the lane by lane data that you can get access to if you're doing specific things on lane utilization. We can draw those in. Our northbound. So we do have to decide where do we want each data set to occur. And so since they can't turn left into this approach, it doesn't actually matter a whole lot. The through that's coming from down here, plus the right turn that's coming from down there will equal this through movement. And conversely, like the through coming from this intersection may include the right from this one down to this one. So we may want to be very specific about which data we're looking at without duplicating it. So often what I like to do is you can configure each one of these on each camera. And so we can include them and then just decide which ones we want later. We got our U-turn here. And then our eastbound, we got our left turn out and our right turn out as well. And we'll hit done. Then we'll go over to the second camera and do the same thing. And what you'll be thinking is that we don't want to duplicate. So we'll decide that in a second, because you don't want to double down on the data. So we just draw the same movements. Oops, did I get my direction eye right? Southbound. Oh, it's a little bit off. So that's southbound. That's actually westbound. Oh, did I get it wrong on the other camera? So go back and double check that. Oh, so I did get it wrong on this side. So this one is actually westbound, southbound. This is our northbound, southbound, northbound. And then we'll go back over to our other one here. And we'll have the same thing. We'll stretch that out. Make sure it fits and make sure we have northbound, southbound, and westbound here. So with dual cameras, you can pick and choose which movements you want. It will validate that you're doing, you're being consistent between each camera. And this one is being a little silly on me because now we need to get this one over here. But we deleted it from the other one. So I guess what I needed to do there, oh, sorry about that. Just go back here, just so I don't lose that. We'll just delete this. We'll just add that back in. This is what it was actually looking for. There we go. Was that it was the same on both cameras. So we got our southbound. And then we'll just decide which ones we want from each camera. So we'll just quickly add those, but we won't have the movements of the one. Delete. Yes. We'll stretch that through. We got about 5 minutes left, so we'll just quickly wrap this up. And then we won't have the movements there. And so because we don't have a left here, this will be kind of whatever. So it does kind of look for all of them, but then it pieces together. We'll choose for each one later, which is a little bit silly, but go. One more of the movements has been added to the configuration. Okay, continue. It tries to highlight where you've gone wrong. Oh. What did I do wrong now? Oh, now it's got me all turned around. All right. Oh, because I have it already configured on the other. This one. It's configuration. So we do got the one already on there, so that's good. And then So in any case, you work your way around all those movements. I know that was kind of probably hard to follow there, but how do we get a count for the actual number of times a zone was activated instead of a turning movement count? So there is a chart. There is a chart that does occupancy of the zones. So it doesn't necessarily count out how many times it was activated, but it will tell you how many times there was an occupancy of that zone. So it's more of an occupancy percentage. And how many times it's just generally occupied. So one of the things that you can look at is how the controller keeps track of that versus how our system actually looks at the actuations. And when we get back to, let me just save this draft and we'll go back to the one page that you can get an output of. So if I go back to the telemetry page here on this page, this one may not be a great example, but it does keep track of how often each one of the zone gets triggered and each one of the phase intervals as well. So from the occupancy charts, you can actually pull out how often were each one of these zones activated, and you can get your chart from that page, which is something that we can get into the next session. So when everything has been configured and everything is done, one way we can validate it, I'll go back to this page and do the detection overlay. And now I didn't actually deploy because this one was actually operating, but let's just pull that back up. Even though there's two cameras here, we have deployed them out together. So now you can see all the different views that we configured and all the different options that you can do across the video all into one frame. So even though you have the two views, there are the two cameras here individually, the detection overlay is actually only on one of them. So that means like we only really need to view it in one spot, and then you can blow that up and look at it at one spot instead of looking at it across two different cameras and trying to make sense of it. You can see all the labels in each one of the movements that you can customize to kind of make sense of it all. You can play the 360 view of the one camera at the same time. I don't know why you would, but you certainly could. And then you can toggle between the two cameras individually. So just to recap, understand the timing plan, understand the detection zone design, understand which movements you want to count between both dual cameras. So do you want some movements from one camera, some movements from the second camera, and we'll keep unpacking that one a little bit, and then really play around with where we're counting from. And then make sure it matches the design you want in the traffic controller. And then once you're happy with that, you can deploy it out and activate the whole intersection for actuation. So it's a nice little streamlined process, and it really tries to help break it down for you so that if you just follow the steps, hopefully you can get through it. Obviously, Miovision technical account managers and all of our partners, we're very well versed in the detection configuration, and we can certainly help you through it all. Our goal is to help you understand it and help you learn how to use the detection so that you feel comfortable with troubleshooting it and operating it, and you don't necessarily need to rely on us. So we're at the top of the hour. Hopefully that was beneficial. Hopefully that allowed you to see some of a unique scenario, kind of a couple of examples of how this could work. Obviously, there's a lot of different variations of this out there, lots of channel designs and lots of count designs. So please reach out if you have anything that you need help with, and we'll keep going. I'll stay on the line for a couple minutes just to see if there are any questions, but hopefully I answered all of those questions in the chat there, and hope everybody enjoys the rest of your day. Thank you so much. Awesome. Doesn't look like there's any questions, so I'll just sign off. Thank you, everyone. Thanks for letting me ramble on today, and have a good rest of your day. Thank you so much.